Hospital Porters, Pride and Dignity, Stop the New World Order. Welcome to Hapanwo TV. A special programme today, and it's all about the Large Hadron Collider, which is at CERN, a laboratory near Geneva in Switzerland. This is the largest and most powerful scientific instrument ever created, and it's finally at full power. It promises to answer some deep and enduring questions about how the universe works, but could it have another purpose? Could it possibly be a doomsday weapon? Could that possibly be true? And if so, what can we do about it? Some of you might find the information you're going to hear in this programme disturbing. In fact, I would say that this programme is not recommended for younger viewers. However, it will have a happy ending. It's not my intention to breed despair and despondency among you. This is not a message of helplessness and going quietly into the night. Right, well, CERN, the Large Hadron Collider. What is it? Well, actually, the Large Hadron Collider is a fascinating thing in itself. It is the world's largest and most powerful particle accelerator, and it's also it's housed in the largest and most complex scientific experimental facility ever built. It is quite simply the biggest machine in the world, and it was built over a 10-year period between 1998 and 2008 in collaboration with over 10,000 scientists and engineers from over 100 countries, as well as hundreds of universities and laboratories. The LHC is contained in a circular tunnel. There's no building in the world big enough to house it. It has to be built underground. You never get planning permission ever to put up something this size. The tunnel actually is huge. It has a circumference of 17 miles at a depth ranging from 164 to 574 feet underground. So it's a project the scale of the Channel Tunnel, basically. And it can be found deep below the ground, as I said, beneath the border of Switzerland and France, near Geneva in Switzerland. Mostly in France, I think. The actual instrument itself is housed inside this tunnel. The tunnel is, as I said, very big, 17 miles around. It's 12 feet wide, so it's about the same size as a London Underground tunnel, at least the deep lines, the bored tunnels. And the tunnel was constructed in the 80s, and it used to be used to house an earlier collider. But then that collider was taken out, and this new one, the LHC, was put in. The tunnel crosses the borders between Switzerland and France at 4 points. And the particles never have to show their passports. Most of it is in France, a little bit is in Switzerland, and there's surface buildings dotted all around it, holding ancillary equipments, compressors, ventilation, control, electronics, offices, refrigeration plants, etc., and the various experiments. Now, the biggest of these there's two, Atlas and CMS, and they are in chambers the size of a cathedral. So these are some of the biggest underground excavations in history. The collider tunnel contains the collider itself, and the pipe where the beam lines run. And this is about 3 feet across, and it looks a little bit like a water pipe or a sewer. It's blue, and that's the impression you get when you see it. And there's two adjacent beam lines inside. These are pipes. These are two pipes that run side by side inside the big pipe. And they intersect at 4 points, each containing a beam, which travels in opposite directions around the ring, and there's extremely powerful magnets needed to keep the beams on their circular path and focused within the beam line. And also where the two beams cross, they have to be targeted very precisely to the point where they cross and collide. And this whole system is super cooled with liquid helium, which is needed to keep the magnets at their operating temperature, which is 1.9 Kelvin. That is just 1.9 degrees above absolute zero, minus 271.25 Celsius. So the inside of that pipe is colder than outer space. And in order to refrigerate it to such a great degree, such a huge device so deeply, takes more electricity than the entire city of Geneva nearby. So it's a pretty impressive system, I must say. Now, the LHC is not the first of its kind. In fact, it's the biggest and most powerful of a whole series of various colliders. Now, there are previous colliders, such as Tevatron, which is at Fermilab, a place called Fermilab, which is at Batavia, Illinois, which is near Chicago in the United States. And there's another one called the Relativistic Heavy Ion Collider, RHIC, R-H-I-C, which is at Brookhaven National Laboratories on Long Island, which is Upton, New York. So these kinds of colliders are they've been built before, but none of them have been nearly as powerful ever as the Large Hadron Collider. Now, the word hadron refers to a particular type of structure, of subatomic structure. It's actually it actually refers to a composite particle composed of quarks. So hadron is like a particle which is made up of smaller particles, and these particles are called quarks, or as Professor Brian Cox calls them, quarks. And they are held together by the strong nuclear force. Now, in the case of the LHC, these hadrons are protons from atomic nuclei. Now, a collider is a particular type of particle accelerator because you can accelerate particles, but this one, the collider, is where the two beams of particles collide together as a part of their use as a research tool. They accelerate these particles, these hadrons, to very high kinetic energies, and then let them impact other particles. And the analysis of the byproduct of these collisions gives scientists some good evidence about the structure of the subatomic world and the laws of nature governing it. And now these byproducts are only produced at extremely high energy collisions, and they decay after very short periods of time, fractions of a second. So they're very, very hard to actually study unless you do have these huge machines to actually collide them together. So these enormous machines, this huge, the biggest machine in the world, is actually designed to collide some of the smallest objects known to man. And the speed and energy of these particles is measured in electron volts. That's the unit of measurement. And how they do this is quite complicated, but it's interesting. What happens is, before the particles are injected into the main LHC accelerator, they are prepared by a series of systems that successively increase their energy. They have to have booster systems, like first gear, second gear, third gear, and then the LHC is the top gear. And the first system is something called the LINAC-2, the Linear Particle Accelerator. The second one they've got that generates 50 mega electron volts proton. A mega is a million, so electron volts, a million of those, 50 of those, and that feeds into the proton synchrotron booster, which you can see here on the little map. It's the tiny little thing at the small circle beside the small circle, the bigger circle at the bottom. So that goes into that, and then that's 150 feet across, which gives you a feeling of the scale. And it's a later edition; it was only put up in the 1970s. Now there, the protons are accelerated to 1.4 giga electron volts, and then they're injected into the proton synchrotron, which is a circle marked PS. That's 600 feet across. That was put in before the proton synchrotron booster. But in the proton synchrotron, they're accelerated to 26 giga electron volts. So gradually it's building up the power. And then they're put into the super proton synchrotron. That's 4.3 miles in circumference. And you see it's the small circle inside the LHC big circle there, SPS. And that's the first accelerator to be built in an underground bored tunnel. It's the first one that's big, and so big it needed that. The others were just sort of cut and covered, kind of buried things on the actual CERN main campus itself. And that boosts the energy to 450 giga electron volts. And then they're at last injected, it takes several minutes to do this, into the LHC. And here there are proton bunches which are accumulated and accelerated over a period of about 20 minutes to their peak energy, and they're close to the speed of light. And at that speed, they do 11,000 revolutions per second of that huge 17-mile circumference ring. And then they're finally circulated for 5 to 24 hours, and then they're collided at 4 intersection points. These are where the detectors are, and they're marked here on the map. And I've got a slightly better map of exactly what these detectors look like. This here is a kind of diagram. It's not to scale. of the various detectors where they actually are. The ring goes through these various detectors, and these rings are called sectors. The sectors between the rings. This is this pipe that goes through this underground tunnel. Now there are 7 detectors altogether, which you can see. They're located in these huge underground caverns I talked about, and one of them is Atlas and the compact muon solenoid (CMS). They are large, general-purpose detectors, but they're smaller ones like Alice, LHCb, and they have more specific roles. And there are 3 more: Totem, Model, and LHCf, and these are very small indeed, and used for specialized research. Atlas is used to look for signs of new physics, including the origins of mass and extra dimensions. Now, the thing about Atlas is it's if you actually look at it, it actually looks a bit like a James Bond villain's lair. I don't know about what you think about that. Have a look. Yeah, definitely, I would say that. It certainly does. Now, on these, when it comes to these sort of like James Bond villains' lairs, isn't the isn't it usually the case in those films that the villain is usually working on some insane scheme to destroy the world? I don't know about that, but that's what I've always found. Anyway, that's the CMS is another general-purpose detector, and it hunts for the Higgs boson and looks for clues to the nature of dark matter. Alice is there to study the fluid form of matter called a quark gluon plasma, or whatever that is, and it existed shortly after the Big Bang. And the LHCb is studying this strange anomaly that equal amounts of matter and antimatter were not created during the Big Bang, which is why we have matter in the universe today. And it's going to investigate what happened to the missing matter. Now, the data produced by the LHC and various other things, it's massive, 15 petabytes per year. And that itself, just simply the computer data, is a major challenge. So the LHC computing grid was constructed as part of the LHC design, and this handles the massive amount of data for its collisions. And this is a massive collaborative international project because you can't keep that many computers in one place. So it's a grid-based computer network, one of the biggest in the world, in 170 computer centers in 36 countries. And there's a big area at CERN. There's a big computer center at CERN, but there's many others scattered throughout the world. And it's a huge fiber optic network. And basically, it takes them a while simply to crunch all the numbers that they gather when they're doing these various experiments and doing these collisions and getting all this data from the detectors. Now, the proposed purpose of the LHC is it will answer some of the fundamental questions in physics concerning the basic laws governing the universe, the forces of the elementary objects of matter and space-time, the interaction of space-time, and the interaction between quantum mechanics, parallel universes, general relativity. At the moment, they don't all know that. Now, these experiments are a step into the unknown, and that is a quote. For instance, they think they found the Higgs boson, but they need to confirm that they found or not found the Higgs boson, or as Professor Brian Cox calls it, the Higgs boson. So that would be very important. Interestingly, the Higgs boson is called the God particle, and I wonder why that is, because I'm going to be talking some more about God later on and about the various occult connections to the Large Hadron Collider. Now, I've heard about the Higgs boson and the Higgs field before I heard about the LHC, and that is because I read some remarkable books. The books I read were by a lady called Juliana Conforto, and this lady here. Now, she's a physicist, but she's also very spiritually and conspiratorially aware. She knows about the Illuminati and things like that. And she's merged her knowledge of physics with her esoteric studies in a way nobody else has done. And her views are based partly on the discoveries of the 15th century Hermeticist Giordano Bruno. Now, Giordano Bruno was the first man to propose that stars in the sky were like the sun and they had planets going around them. And he was burned at the stake on New Year's Day 1600 by the Vatican for his beliefs. And at the place in Rome where he was done, there's actually a memorial to him at the crossroads where he was burnt. And Juliana Conforto's own model of the spiritual universe has the Higgs field as its center, and she's written books like LUH, Man's Cosmic Game, and The Organic Universe. And I don't think she's ever met Professor Brian Cox, but if she did, I don't think they'd get on very well, quite frankly. Something tells me that. Now, the history, its operational history. On the 10th of September 2008, the LHC was started amid a huge press fest at the CERN laboratory. And they call that the startup of the LHC, but in fact, it's not like sticking a key in your car ignition and turning it. There's no single moment when you can say this is started up. It's just that was when they first started circulating beams in the pipes. But it was a massive media launch moment. The clockwise beam passed round the 8 waypoints, then it passed around the other way round. At that point, the project had cost $6 billion US. Now that's enough to build the John Radcliffe Hospital almost 3 times over. So the LHC is the most expensive scientific experiment and instrument ever built. And when this happened, there were reports in the media that the world was about to end. I'll be saying more about that later. Now, it was a month or two before they fine-tuned everything to allow the first low-power collisions to take place. But they got working on that. They got working on that pretty soon. And before long, it was at half power. They did some half-power collisions during the first, what they called Run 2, the first experimental run, and it produced some remarkable results. But it was only at half power at the time. Now, something very interesting happened on the 19th of September 2008. So this was just a few months after it was started. A magnetic quench occurred. This is a disastrous incident in which some magnets fail, and there's a loss of electrical power, and the liquid helium inside the pipe escapes because it's not refrigerated. So it basically flashes back into gas and it bursts out of the pipe. And this damaged a lot of the pipe. And no one knows what caused it, interestingly. And I'll come back to that, actually, because that's very important. But anyway, on the first operational run of the LHC, low-energy beams were circulated in the tunnel for the first time since the incident on the 20th of November 2009. So it was shut down for over a year. And on the 30th of November, the LHC achieved 1.18 tera-electron volts per beam. And that made it the world's highest energy particle accelerator. And that beat the Tevatron Collider's previous record of 0.98 tera-electron volts per beam. That's not the collisions, that's each single beam. The collisions are twice as powerful because of Newton's laws of motion. And then in 2010, the ramp up of the beam energies continued until they were 3.5 TeV per beam. And on the 30th of March 2010, the LHC set a new record for high energy collisions. It collided the proton beams. These two 3.5 TeV ones had a combined energy level 7 TeV. That's the half power mark I told you about. And that's where they started the research. That's when the data tap turned on. And on the 24th of May 2011, it was reported that quark-gluon plasma... Quark... I have this... Whenever I say that, I have this urge to say it in Professor Brian Cox's voice. Quark-gluon plasma! Oh, yes, that's how the Coxer would say it. Which is the densest matter believed to exist apart from black holes. Now, in 2013 to 2015, the whole thing was shut down and it had a 2-year upgrade, which would increase its power, enhance its detectors, strengthen its magnets. And then the second operational run began. Now, the second operational run of the Large Hadron Collider was given a rather demure name, Run 2. On the 5th of April 2015, the LHC officially restarted after a 2-year break to be upgraded to run at its full specified operating energies of 7 TeV per beam, which makes 14 TeV in collision. Originally, it was run at 6.5 TeV per beam, 13 TeV in total, but actual collisions began last month. The first ramp-up was on the 10th of April 2015 at 6.5, and eventually, on the 3rd of June, the LHC started colliding and delivering physics data. No results reported yet of the 3rd of June, but it's an interesting thing. This is what you see now is a graphic that's been released by CERN of what these explosions look like in terms of a diagram. Now, these very high energy collisions, when they collide in the bowels of the machine, and these are enormous explosions. They are like nothing ever seen on Earth before, maybe even seen in the entire universe. This scale of force is unprecedented. It's bigger than the Big Bang. Now, when I say explosions, it's a bit strange because there's no shockwave, there's no noise, there's no boom, there's no flash of light. It's not like an explosion. The word explosion conjures up that image. It's not. You could stand actually in the middle of these collisions and be completely unharmed. In fact, you wouldn't see, hear, or feel a single thing. But nevertheless, these are going on, and on the fundamental level of the workings of the universe, it's being basically shattered. But the Large Hadron Collider has actually entered popular culture in a way very few scientific projects do. It's inspired fiction, a lot of fiction, novels, TV series, video games, and movies. Now, the book Angels and Demons by Dan Brown is a somewhat lesser novel to his Da Vinci Code, but it's still interesting because some of it is set at the LHC, and it takes part in the creation of antimatter, and that's not realistic, but I will come back to the weapon angle. Now, there's a short story called Breakthrough by Tom Morris. And it's very short. You can read it in about 10 minutes. It's only a really short story, but it's really good. You can get it online. Just put in Breakthrough by Tom Morris. And it talks about some of the things I'm going to be talking about, the unexpected and alarming consequences of LHC experiments. And the LHC was also the focus of the 2012 student film Decay, which was filmed at the CERN in the maintenance tunnels, and it's a comedy about zombies, and I'll be talking a bit more about that later. And there's a documentary called Particle Fever too. So there's a lot. It seems to be everywhere. Everyone's talking about it. Everyone's going on about it. It's quite interesting. And so, I mean, I've already looked into a few of these things already. Now, CERN itself is interesting. This is like this big ball-shaped thing, which is at the laboratory. That's one of their first ever constructions. And CERN actually stands for the Conseil Européen pour la Recherche Nucléaire, CERN. Now that's French. Basically, it's French for the European Organisation of Nuclear Research. And interestingly, the World Wide Web began at CERN, and at the Mayrin computer facility, they've got the first ever web server still there. The actual CERN began in 1954. Now this is interesting. It sits on the border of France and Switzerland. It's in both countries. So it's almost like it's a sovereign state of its own, and that comes in later on because someone did try to sue them, and they had a lot of trouble because of this, because they tried going to the courts of France and Switzerland, and both those countries said that, well, it's not in our country, it's in the other one. That's interesting, isn't it? But it's the biggest particle physics laboratory on Earth. 21 European member states run it. Central facilities have 2,500 staff. And it has hosted some 12,300 fellows, associates, and apprentices. Lots of visiting scientists and engineers representing 608 universities and research facilities of 113 nationalities. So this is the background to what we're going to talk about. And there was an interesting event actually a short while ago about faster than light neutrinos being discovered, and I don't have time to tell you about that in this particular program, but maybe I'll cover that in another, because nothing should be able to travel faster than light according to Einstein's theory of relativity. Yet CERN did discover something that did, and it was very quickly brushed over, as things tend to get brushed over when they don't fit in with the narrative. Now, long before the LHC was built, there were already some people discussing whether it was actually safe to carry out these high-energy particle collision experiments. As I've said, these explosions that the universe has never seen before. And by their own admission, it's a step into the unknown. And this was a topic of widespread discussion before the LHC, when the Tevatron and the Tevatron at Fermilab and the HRIC, Relativistic Heavy Ion Collider, were started. This was long before the LHC opened at CERN, decades before. And the concerns were that such high-energy experiments might produce novel particles and forms of matter that had the power to create harmful states of matter and even doomsday scenarios. Because of these high energy levels were involved, these extreme energies might trigger unforeseen problems and consequences, and there were some risks that some people had speculated on. And there were two main problems. One was that the collisions might produce mini black holes. This is what they are, mini black holes which are tiny. Or strangelets. Strangelets in the night. La la la, strangelets in the night. Sorry. Forget I said that. I just couldn't resist that. Now these strangelets are a particular form of matter that converts all normal matter around it into fellow strangelets with explosive force. And so these questions were explored. And in fact, the LHC actually created a group of independent scientists which they mandated to review these scenarios. This was called the LHC Safety Assessment Group, LSAG. And they issued a report in 2003 that they concluded that, like current particle experiments like the Tevatron and RIC, the LHC particle collisions pose no conceivable threat. A second review of the evidence commissioned by CERN was released in 2008. This report was prepared again by a different group this time, but they reaffirmed the safety of LHC collisions in the light of further research conducted since the 2003 assessment. It was reviewed and endorsed by CERN by a committee of 20 external scientists and by the Executive Committee of the Division of Particles and Fields for the American Physical Society, and it was later published in the peer-reviewed Journal of Physics G by the UK Institute of Physics, which also re-endorsed its conclusions. Well, the court ruled out any doomsday scenario, apparently, at the LHC. Concerns about possible adverse consequences were raised in connection with the Tevatron and RIC particle accelerators. And after a detailed study, the scientists reached the conclusions as beyond reasonable doubt, heavy ion experiments at RIC will not endanger our planet, and there is powerful empirical evidence against the possibility of dangerous strangelet production. Well, you see, despite this, though, the safety concerns about the LHC attracted a lot of media attention, and they were widely circulated in newspapers reporting doomsday fears. The Times, The Guardian, The Independent, The Sydney Morning Herald, Time Magazine, CNN all said that some had expressed fears that the project could lead to the Earth's demise. That's a very serious matter. You can't blame people. The scientists said it was baloney. John Huth, in particular, was quoted. And the BBC carried out an online survey which said that the scientific consensus appears to be on the side of the CERN theorists. There is no conceivable danger, and the public know enough not to panic. And Brian Greene of New York Times, the science correspondent, said, again, the answer is definitely no, that there could ever be black holes or strangelets produced in these various experiments. Now, as I said, this was not a concern that came up just because of the LHC. It dates back to the previous colliders, such as the relativistic heavy ion collider, RHIC. Now, when I first said, I thought that was a swear word in Welsh, but it's not. It is a Welsh word, and apparently it means notch. Anyway, when it started operations, critics postulated that the extremely high energy could produce catastrophic scenarios, such as creating a black hole and strange matter, but also something else called a quantum mechanical vacuum. And I will come back to that later. Now, physicists struck back. They said that objects like the Earth the cosmic ray particles are much higher in energy than that of the LHC or any other man-made collider like RHIC or Tevatron. So it's a completely unfounded hypothesis. However, a new story emerged on Friday the 18th of March, not the 13th, luckily, 2005, which said this: a fireball was generated in a US laboratory that resembles a black hole. Brown University professor Horiatio Natase, that's Japanese, I'm sorry if I've mutilated that word to my Japanese listeners, viewers rather, has written a paper detailing calculations that suggest that a fireball created in the Rik may have been a black hole. The fireball occurred as scientists conducted experiments involving the smashings of streams of gold nuclei together in the Rik, and it's reported to have been 300 times hotter than the Sun. It absorbed more than 10 times the predicted amount of energy as it and radiated it as heat, a behavior characteristic of black holes. Scientists have reassured the public that this phenomenon does not pose a threat. The fireball existed for 1/millionth of 1/billionth of 1/billionth of 1 second and was not dominated by gravity, as previous black holes have been. So concerns were raised in connection with the Rik, both in the media and in the popular science media. And Martin Rees said that there was at least a 1 in 50 million chance that there would be a doomsday scenario. And Professor Frank Close, who's Professor of Physics at the University of Oxford, and I think he did a Royal Institution Christmas lecture a few years ago actually, he indicated that the chance of this happening is like you winning the major prize on the lottery 3 weeks in succession. The problem is that people believe it is possible to win the lottery 3 weeks in succession. The thing about it is, Close actually said this on a BBC documentary called The End of Days. It's BBC Horizon, and I've talked a little bit about that in the past. The thing about it is actually possible physically to win a major prize on the lottery 3 weeks in succession. It's extremely unlikely, but nothing is so unlikely in this universe. So nothing physically possible in this universe is so unlikely that we can say this can never happen. So, are you reassured? I'm not. Now, the history of this conflict is very interesting because the debate was started by this man, Walter L. Wagner. He was joined by 2 other guys, Otto Rüssler and Frank Wilczek. And he basically stirred up a lot of the media stories concerning the Large Hadron Collider. And he exchanged emails with the director of the Brookhaven National Laboratory, J.H. Marburger. Sounds like the Marburg virus, doesn't it? Oh, I'm sure that's just a coincidence. Anyway, Marburger ruled out catastrophic scenarios, but the report left open the possibility that the cosmic ray impact products might behave differently as opposed to the products from Rik. And because I'll come on to this later because another guy actually does an analysis of this. But Wagner actually tried to sue Rik. He tried to stop full energy collisions by filing federal lawsuits in San Francisco and New York, but he wasn't successful. It was a bit of a technicality, actually, very unfortunately. The New York suit was dismissed on the grounds that the San Francisco courts were the preferred forum. The San Francisco suit was dismissed because for the very same reason, saying to do with the New York courtrooms. But there was leave to refile, so he could appeal if additional information was developed and presented to the court. But yeah, it was all. That's how it started, basically, with these various lawsuits, and that wasn't the only time Wagner decided to take legal action. Now, this here is Otto Rüssler, Wagner's comrade in arms over this business, and so obviously he was unsuccessful with Rik. But in the run-up to the commissioning of the LHC, Wagner was joined by this guy, Rüssler, and Frank Wilczek, and a Spanish science writer called Luis Sancho, who's also a movie producer and has made a film about this whole business called Strange Matters. And they all got together and expressed concerns over the safety of the Large Hadron Collider. And they attempted to halt the beginning of the experiments through petitions to the US and European courts. Now, at some point, Wilczek changed his mind. He swapped benches. He betrayed Rüssler, Sanchez, and Wagner, and he decided to join the crowd who said, no, these things are safe. So he changed his mind. He's been doing some couple of lectures, basically taking the mickey out of his former comrades, and it's quite amusing to see the two of them fighting, because in Sancho's film, they really have a go at Wilczek. It's really funny. But the US, this is interesting, based on their concerns, the US federal judge, Richard Posner, sustained actually sustained their objection temporarily. And that wasn't all. The Romania's Conservative Party held a protest at the European Commission's mission at Bucharest, demanding that the LHC be halted. This was before it was switched on in 2008, because of the fears of the dangers I've described. And the Large Hadron Collider team started receiving death threats and threatening emails, phone calls. And this obviously, I should point out, a bit of a disclaimer here. This is not something that I advise. Okay, I would ask you not to carry out threats or any violent action against anyone because of what I'm talking about in this film. Understood? Jolly good. Anyway, of course, the tabloids covered it as well, like the tabloids do. You know what they're like. The Daily Mail, of course. Are we all going to die next Wednesday? And then when nothing happened on that Wednesday, when they switched the LHC on, end of the world postponed. Oh no, that was what the Sun actually put that in as well. End of the world postponed when the LHC broke down, when it had the magnetic quench incident in November. So it is in. So that's quite strange, actually, isn't it? Anyway, they quoted Otto Rüssler too, which is interesting. And what they did was they said the feeling was when the machine was switched on in 2008. A few of them sort of celebrated and said, well, the world didn't end, so there's nothing to worry about. Well, that's not quite as simple as that. And I'll actually let Walter Wagner explain that to you in his own words.
From the heartland of America and the gateway to the West, good morning, good evening, wherever you may be across the nation, around the world. I'm George Norrie, and welcome to the world's most listened to late-night talk show, Coast to Coast AM. Dr. Walter Wagner is our guest this hour. He graduated from Berkeley with a minor in physics, a major in biology. Later, he discovered a particle in a balloon-borne cosmic ray detector, initially identified as a magnetic monopole. Though its identity now remains uncertain, it is definitely not within the standard repertoire of known particles. He's an expert in physics. He's an expert on what's going on at CERN, and he's our guest this hour. Walter, how are you?
Good evening, George. I'm doing great.
Good. Now CERN, they're going to turn that on soon, aren't they?
Well, it's already in the cool-down stage. It's not just a single switch that you do. It's a very complex process. And the large 27-kilometer diameter ring where the particles will be accelerated has to be operated at a temperature of about 2 degrees Kelvin. That's the temperature of outer space. And that takes a long process of cool down, starting off initially with liquid nitrogen to cool it down to liquid nitrogen temperatures, and later with liquid helium to cool it down to liquid helium temperatures. And they're in that process. It'll be about another month before it's reached operational temperature. And then they have to inject beam into the ring, and that takes a couple of months to get that done if everything goes according to the design.
Now, Walter, this particle accelerator is built underground, correct?
Yes, it is.
How far down is it?
Oh, it varies, of course, from the surface. It's on the order of 70 meters or so. It's not real deep. I believe it's in some places 100 meters. It's underground because when you are running these high-speed protons or other particles through this ring, they produce what's called synchrotron radiation. And that is a very high-energy photon, very penetrating, and it goes through several feet of dirt. And so put it under 100 feet of dirt, and you're safe.
So that's why they went down that way.
That's why, right. It makes it a lot easier. Also, it out of sight, out of mind. They don't have people thinking about it.
Now, are we correct, those of us who think that something could happen if this isn't done right? Or are we way off base?
We're exactly correct, George, and that's the unfortunate part about this. There have been reviews that have been done that have confirmed the things that I have been saying. Reviews done by the people at CERN themselves, and so it has given them cause for great concern. And in addition, the great promotion of Hawking radiation as being the fail-safe that would save us is also admitted that it's a 50-50 chance of whether it would work or not. So we're we're looking at something that has the potential to be very disastrous without any kind of a safety net that we can use to prevent anything bad from happening.
Okay, now tell us, Walter, what's the downside here then? I mean, what could go wrong?
Well, probably the easiest one for people to understand is the potential for creating a small black hole. There are, under normal theories, these things would not be created because there's not enough mass involved in when these two particles collide together. You end up with the mass of several thousand atoms squeezed into a very small volume. And under most theories, that's not enough to make a black hole. But under some theories involving extra dimensions of space and time that we don't normally see in our three-dimensional space, one-time dimension in which we walk around in, if there are additional dimensions, it's possible that it would allow for the creation of a miniature black hole or micro black hole. And there are some theorists who have predicted that this could be the case, and that the energies, or the energy density, I should say, of the Large Hadron Collider might be able to create such a creature. And if that were the case, it could potentially grow larger and eventually, over the course of decades to millennia, devour the Earth.
Literally suck the planet right in.
Well, yes, it would not occur instantaneously because it would start off so small that it would have difficulty interacting with the atoms, with the nuclei of the atoms of the Earth initially. But eventually, as it slowly did, every now and then it would interact and suck in a nucleus. Over time, it would get larger, and that process would accelerate. And so eventually it would be able to do it at a very rapid rate. And how long that would take, no one knows. There are estimates. One theorist in Germany, Otto Rissler, has estimated it could be as short as 5 years. I've seen other people say it could be as long as 1 billion years, and everything in between. We really have no way of knowing.
What a bizarre story. Okay, if for some reason let me ask you this. Is that only in the event something technically goes wrong with their experiments, or by the mere fact that they get it running in 3 to 4 months, that it will be created automatically? It's going to happen regardless.
Well, it would happen automatically. Yes, it's not like if something goes wrong. They're trying to create new matter, new forms of matter that have never been seen before on Earth, and there are several different theories as to what kinds of things can be created, and some of the theories are that you could create a micro black hole. There's another particle called a strangelet that some theories predict might be able to be created as well. And it would have a similar kind of disastrous consequence, but exactly the opposite, actually. It would end up in a runaway fusion reaction, creating atoms into itself and growing larger, but releasing fusion energy, and eventually would heat the Earth up to where the Earth exploded. Instead of imploding like a black hole, it would explode like a supernova.
Initially, if this happens, where would it be? Would it be centered around CERN in Switzerland? Is that where, let's say, this little mini black hole might be?
No. It would, if it were to make one, most of them would be at very high speed relative to Earth, nowhere near the speed of light, but still several 100,000 miles per hour. But there would be a few of them that would be at below the escape velocity for Earth, which most people know is 25,000 miles per hour, to break away from Earth's gravitational pull completely, so you get to leave the Earth and are no longer a satellite around our planet. But if there are some of these black holes that are produced with speeds below that, they would become a satellite, if you will, around planet Earth and orbit around and through our planet. There would
How weird.
It would spend perhaps an hour traveling through the planet and then several hours up into space and then back down for an hour through the planet and several hours up through space, and just keep on in an orbit like that. Every time it sucked up an atom and grew a little bit larger, its orbit would shrink a little bit, grow a little bit smaller. Eventually, its orbit would be entirely within the Earth, and eventually orbit would start shrinking small enough that it would sink towards the center of the Earth.
Oh, maybe it's not nice to play around with Mother Nature, Dr. Wagner, huh?
Well, it depends on how you're playing around with it. There's nothing wrong with doing passive experiments or observing what Mother Nature puts out there. We have a lot of satellites out there observing nature, and there's nothing wrong with that. We have telescopes observing nature. There are a lot of things we have done which we have very good control over, and there's nothing wrong with doing those kinds of works. Some people have said, well, if we never experimented with nature, we'd never acquired fire, and that's true. So there are some experimentations that's perfectly acceptable. But once you have identified some problems, you have to be able to prove that they're not going to happen. It'd be the same, no different than if you built a dam over an earthquake fault, and later on you found out there was a
Welcome, everyone. We are here to discuss a topic that has recently sparked interest. I'm here with Dr. Walter Wagner. So tell me, Dr. Wagner, why did you become so interested in such a controversial but yet unusual subject?
Well, I became interested in this about 10 years ago when it was first being planned. And I have a strong interest in astrophysics and cosmic radiation physics and this kind of research. And my interest in this field made me realize that there is a potential for creating new kinds of particles with this collider that have never been created before. And that there is a potential hazard associated with that if some of these new particles don't disappear. If they end up lingering and lasting, they could potentially end up being disastrous for our planet.
And when is this experiment going to take place?
Well, there is no firm date set as of yet here in June of 2008, but it is estimated that they will be ready to begin the experiment sometime in late 2008, possibly October or November.
And what are the possible side effects from this experiment?
Well, if it creates this waste product that we've discussed with a number of scientists, this waste product could be either a micro black hole or a strangelet. There are two different scenarios that could conceivably occur. One of those is in which the micro black hole doesn't disappear quickly the way it's anticipated will happen. Instead, that it would be able to possibly grow larger and become a small black hole, consuming the entire planet. The other one is if a strangelet were to be formed and did not rapidly disappear, if it were to then start adding on other atoms to itself in a non-stop fusion reaction, it would eventually consume the Earth and make it into a supernova.
Wow. So I understand that you have a lawsuit against CERN. Tell me, what is this lawsuit going to do, and who is CERN?
Yeah, CERN is an acronym, and it's actually the European Center for Nuclear Energy Research, and the CERN is actually the old acronym name they still use. And it's located in France and Switzerland, right on the border, and it is a 27-kilometer diameter machine, and the lawsuit that we filed was filed in March, and we filed it because we were initially told by the CERN management that they would have a new safety study addressing these issues that had been overlooked in previous safety studies, and that this would come out on January 1st of 2008, if not before. And that didn't happen. So 2 months later, they were supposed to have released it based on a letter they wrote me, and that would have been March 1st of 2008, and they still didn't release it. So not long after, we decided that we should file a lawsuit to make certain it gets released and that these issues are thoroughly addressed, not only by CERN, but that other people can have a chance to review their work, because these are the kinds of scenarios that are just too serious of a concern to leave to persons who have a personal and financial interest at stake, as well as their scientific interest.
So what are some of the ways you have raised public awareness with this experiment?
Well, of course, the lawsuit has raised a lot of awareness. I have also developed a website. Other people have developed websites. I blog on a number of other science forum websites, and I exchange emails with a number of scientists about this.
And why isn't this controversial topic publicized in the news?
Well, it's been in the news some, not anywhere near as much as I would like to see it, because by being in the news, it's putting pressure on CERN to come up with and release this safety study, which they have delayed doing. The reason they've delayed it, I believe, is because they have not been able to refute some of these disastrous scenarios. As to why it's not in greater interest, I think it's partly because it's still several months away before they're ready to begin, and I think it's also partly because people don't like to think about this. It's too depressing.
Yeah, they don't want to believe that the world...
They don't want to believe that this is something that was overlooked. CERN didn't want to believe that this was something that was overlooked, and it in fact is. They've recognized that now, that there are some safety issues that were not addressed initially in previous safety studies that are a very serious concern, and they've made some fundamental errors in their previous safety studies, which we pointed out to them, and that's somewhat embarrassing for them.
Wow. Well, thank you very much, Dr. Wagner. I hope that your initiative will raise the awareness of this particular experiment and of the ethical aspects of science as a whole.
Well, thank you. I enjoyed having the chance to speak.
On the 10th of September 2008, tragedy struck. This was the day that the LHC started. Chaya Lal, a 16-year-old girl from Sarangpur, India, committed suicide. She hadn't been listening to Wagner, apparently, or Russler. She'd just been distressed over the secondary media reports all over the world, going on about how the world would end once the LHC was switched on. She went out one day and she drank poison. And I really want to avoid this, okay? I don't want anyone watching this film to despair, because this film is going to have a happy ending, alright? I think this situation is going to have a happy ending. Now I'll address these specific concerns. One of these is that the micro black holes could come out 1 per second from the reactions. Now, according to standard calculations, these are harmless because they will quickly decay via Hawking radiation, named after the famous wheelchair-bound scientist. Hawking radiation is a thermal radiation predicted to be emitted from black holes due to quantum effects. Because Hawking radiation allows black holes to lose mass, it means that black holes lose more matter than they gain, and so over time they dissipate, shrink, and ultimately vanish. And so micro black holes are similarly predicted by the theory to vanish too, and they are very large net emitters of radiation, even more so than full-size black holes. And so they shrink and dissipate very quickly, within a tiny fraction of a second. And the LSAG actually said there is a broad consensus among physicists on the reality of Hawking radiation, but so far no experiment has had the sensitivity to find direct evidence of it. Now, strangelets are slightly different. A strangelet is a small fragment of strange matter. This is a hypothetical form of quark. Now, quarks come in different types, flavors they're called, up, down, top, bottom, and strange and charm. And they are extremely stable. That's the thing. They're very, very stable indeed. Now, if they exist, they could possibly be produced by the LHC or by HRIC and other of these hadron colliders. And the danger is that what happens is a strange quark, when it encounters a normal quark, it turns it into a copy of itself. And so you have a kind of runaway fission reaction in which the various quarks, all the quarks then is a chain reaction. All the strange quarks would expand, gobbling up all the normal quarks, and eventually you get what's called a strange star. And ironically, the probability of the creation of strangelets decreases at higher energies. So in that respect, the LHC is less dangerous than the HRIC or the Tevatron. And so that's an interesting little twist there. Now, according to the defenders of the LHC, models indicate that strangelets are only stable at very low temperatures. So they would be stable inside the pipe of the LHC, but the moment they left that area, they would disintegrate. So basically what they're saying is it would be like ice forming spontaneously in boiling water. That's the kind of analogy they use, and I suppose, is that accurate or what? I don't know, but that's what they're saying. But anyway, Otto Rissler, he argued that micro black holes could grow exponentially. And on the 4th of July 2008, he met with the CERN physicist Rolf Landauer, with whom he discussed its safety concerns. And following the meeting, Landauer asked another expert, Hermann Nicolai. Sorry, I'm throwing lots of names at you. It's all right, bear with me. He asked this Hermann Nicolai as director to examine Rössler's arguments, and Nicolai reviewed Rössler's research paper and issued a statement highlighting logical inconsistencies and physics misunderstanding in Rössler's arguments. Nicolai concluded that this text would not pass the referee process when it comes to serious journals. And they go on to say a few more things about relativity and how there's no logical connection between his paper and what could happen at the LHC. And there were several other open letters and various articles published saying that the LHC is safe. Yes. Now, Otto Rössler actually set up a meeting with the Swiss president, Pascal Couchepin. What a name. I think it's probably Couchepin or something French-like. This was in August 2008, but Couchepin cancelled the meeting because he got some criticism by saying that he thought he was giving Rössler and his fellow opponents a chance to update their publicity. Anyway, on the 10th of August 2008, a German astrophysicist called Rainer Plager, who's also a blogger, he concluded that the ALSAG studies had not definitively ruled out potential catastrophic threats. And also, he wrote several papers about this. Now, Stephen Giddings and Michelangelo Magano challenged him, and they pointed out that there's a basic inconsistency there. And they said that Plager was wrong, and this to and froing went on. And eventually, there was a paper published in the journal Physical Review D that ruled out the catastrophic growth of black holes and strangelets. Now, Plager replied with another paper, but that's so far not been published in a peer-reviewed journal. But this kind of went on. It was a kind of to and froing, a debate, a scientific sort of long, drawn-out scientific debate. But legal challenges continued. Walter Wagner and Louis Sancho organized against CERN and its American collaborators. The plaintiffs demanded an injunction against the LHC's activation for 4 months because of the ALSAG's recent safety publications, which they thought weren't adequate, and a permanent injunction until the LHC can be demonstrated to be reasonably safe within industry standards. And there was a hearing over that. Now, the ALSAG issued its own response to that, saying there was no basis for any concerns. So there was basically the US government called for a summary dismissal of the suit. And this is when this issue came up about, well, where is CERN? Which country is it in? We don't have jurisdiction over it. But Otto Rössler continued. He filed another suit in the European Court of Human Rights in Strasbourg. That was rejected too. So basically, on the same day, they basically this what it was. Rössler was saying he worded it very carefully. He said that the Large Hadron Collider could pose grave risks for the safety of the 27 member states of the European Union and their citizens. That's a wonderful legal understatement, that, isn't it? Now, they went to Germany as well. In February 2010, there was Wagner and Rössler and Sancho went to Germany to try and get an injunction to halt the LHC's operation. Because remember, the LHC is international, so any one country could actually veto involvement in the LHC. That was rejected. They appealed. That was rejected. Now, the rebuttal by Louis Sancho is interesting because he's made a film called Strange Matters, and he's got a website called Louis Sancho. The YouTube channel, LuiSancho, and the film is called Strange Matters. And he says that the cosmic rays being higher power, and so therefore, if they don't do any damage, the LHC won't do any damage. He says that's a bad analogy because cosmic rays are not hadrons. They are not quarks. Particles in an accelerator behave differently. There's less velocity to them. They remain within the Earth's gravitational field. Also, he didn't buy the idea about Hawking radiation dissolving these mini black holes because now black holes apparently can't radiate anything because gravity exceeds the speed of light. So therefore, any form of radiation would also not be able to escape from the black hole, because that would be a breach of the laws of thermodynamics and entropy. So it'd be a kind of perpetual motion. But, well, that's a bad way of putting it, because I've looked into perpetual motion, free energy, and things like that. But I mean, the point Hawking was making is this is a quantum effect, and quantum effects can exceed the speed of light. For instance, entangled particles, which are at enormous distance from each other, they respond to each other's movements instantly, even if they might be a million light years apart. It'd be great, actually, if we could make a communications device with these entangled particles, because then we could talk to people in distant galaxies on the phone. You know, we wouldn't have the aliens could just call us up. We wouldn't have to worry about the speed of light thing. And the Rick has already produced some of these strange liquids and things like that. Now, there is evidence that some people said that strange matter itself is simply speculation. But Sancho said no, because pulsars, these super dense neutron star type things, are said to be made of strange matter. So strange matter is out there, and that's the point, and that's the point Sancho's trying to make in court. Unfortunately, none of the courts bought it, which is a shame. But, well, depends on your viewpoint. I'll go into a bit more of that later. Now, supposing the LHC is dangerous. If it is dangerous, could it be intended to be? This is an important point. And I've amended my viewpoints on more than one occasion since I first wrote about this in 2008. The power of the LHC is still increasing, and it's due to reach full steam sometime about now, actually. Now, there's actually a statue outside the CERN laboratory decorating its front entrance. It's not one of Albert Einstein. It's not one of Isaac Newton. It's a statue of the Hindu god Shiva. This one, you can see before you now. Now, Shiva is the oldest recorded deity on Earth, and his image appears on cylinder seals found in the ruins of ancient civilization in that part of the world. And he is a supreme god in the Hindu mythology. He's the most mighty of them all. I say he, but he's sometimes a she. Gods don't have a human gender in Hindu mythology. And he's charged with the destruction and transformation. So he's a very strange figure to decorate a scientific institute with, I would say. Now, the statue was donated by the Department of Atomic Energy in India. Now, I've said before many times that the Illuminati love mythological and occult symbolism. And this reference to the Hindu pantheon is not without precedent in scientific works to create means of great destruction. In 1945, a very perturbed and regretful Robert Oppenheimer was interviewed on film shortly after the Trinity test, where the first atomic bomb was exploded. And he said that his invention, the atomic bomb, brought to mind the words of Lord Vishnu in the Bhagavad Gita. Now I am become death, the destroyer of worlds. Now there's also a 666 in the CERN logo. Now, can you spot it? You see, there is a 666 encoded into this image, into this motif. This is weird, isn't it? Why is it? The Loomies, they have to drop hints. And I think it's for occult reasons related to karma. By telling us what they're doing in advance, they're giving us a tacit mandate, which relieves them of accountability in their belief system. And it could also be simple vainglory. I mean, the Illuminati feel enormous contempt for we, the ordinary people. They call us goyim, cattle. They actually get pleasure out of toying with us. I think there is an element of that as well, which should not be underplayed. Now, in the run-up to the start of Run 2, there was an experimental dance troupe at work called Symmetry, and they did a show at CERN, which was filmed. It was turned into a kind of short movie, and their routine was performed inside the LHC. And you can actually watch it. It's on Vimeo. It's only about a quarter of an hour long, but it has things such as it's not only filmed with people dancing around CERN, but it's also contains themes of beings from other dimensions breaking through, which I'll talk about in a little while. And do you know what they call this dance? It's called Shiva. Couldn't be more blatant, could they? Now, decay. Now this is a this may have been generated by a subconscious sense of catastrophe, and it was actually made by some of the younger members of the CERN staff, student apprentices, and it's a zombie movie produced by these guys, these students, and it's a low budget spoof, and it's actually quite funny, but it is disquieting because of this connection. Not only because of what I've already said about zombies as themselves, I've done a whole series of videos on zombies, but it's weird these two things come together, the zombies and the LHC, both at the same time. I think that's rather an unusual connection, and well, I'll have to watch the film. It's amusing. It's quite a good film, actually. It's almost a spoof, kind of like a bit like Shaun of the Dead, just a joke kind of thing. I hope you enjoy it. So the question is, what's going to happen next? Now, why are they doing this? This is the question. Why would the Illuminati, who are seeking their New World Order, want to destroy the world on which this New Order is going to take place? And I think they might be planning a Götterdämmerung maneuver. I think this is one of the reasons they're doing fracking as well. They want to destroy everything. They want to destroy the world, or even the whole universe, because they know they're going to lose it. And they'd rather it all went down to hell than let free people have it. It's an extremely spiteful kind of dog-in-the-manger type attitude. It's a kind of global scorched earth policy. And it first came to my attention because I was listening to a coast-to-coast show with Jeff Rense. He was interviewing David Icke. And I can't quite recall the words, but Jeff said something like, to the effect of, if the Illuminati know they've lost, that their dominion is over, and the New World Order can't be achieved, they're the kind of people who would destroy the earth before they'd rather just destroy everything and go down with it, with all of us together, than just lose and let us have it. And I can see where Jeff is coming from. And I've named this mindset Götterdämmerung. Now, Götterdämmerung is an opera by Wagner, and it means Twilight of the Gods. And I've observed this kind of dog-in-the-manger attitude at all levels of human conflict. I mean, imagine if I nicked one of my brother's toys when I was a little kid once, and my mum and dad said, give it back, give it back, give it back. And I remember I threw it across the room and smashed it, rather than give it back to him. Then we both lost it. So you see what I mean? I think they do that, even if it meant their own destruction. I mean, ideally, they'd like to live on the world under their jackboot, but if they couldn't do that, they would destroy the Earth out of spite, and the whole universe. The Illuminati are notoriously self-glorifying and arrogant, and failure is something they've never before had to consider. Now, there must be some, maybe, people within the higher echelons of the Illuminati that must understand that their game is reaching its end, and it's not going to happen. Human consciousness is getting wide, it's starting to fight back, and it's going to overtake them. So could the LHC have been deployed as part of a reaction to this? I mean, one part, are there others? And a part that's been created secretly. And I mean, innocent scientists have built it unknowingly, unaware that they've really been co-opted into a doomsday device. And that innocent scientist, I include His Royal Cocksness. I mean, I'm not a fan of his, but I don't think he's out there to destroy the world. Now, the psychologist Erich Fromm said something very interesting, and this is what Sancho talks about in his film. Because it can be built, it must be built. Its value or danger is irrelevant, which means that just because people can do something, they will do it anyway, even if it means our destruction. And Erich Fromm was a psychologist. He's also a member of the Frankfurt School, a cultural Marxist, so it's very interesting that he said that. Unless there's some kind of enormous power at the LHC which they're using for a positive mission to do something that will achieve the New World Order, that they actually want something that it can do. Maybe if because this object, this machine, has the power to mine the very fabric of the universe and expose all its quantum mechanical workings to scrutiny. Now, who knows what that effect will have? A quantum wave collapse that changes the entire universe? Or it might break the New World Order, but maybe they're willing to take that risk. Because we are living in this pivotal time, predicted by both Mayan mysticism, Western mysticism, and secular analysis. Maybe they're willing to take big risks, and I'll come back to that. Now that wheelchair-bound Cassandra, Professor Stephen Hawking, has once again foretold the end of the world. Now, he's done this before. He's a great believer in the dangers of alien invasion, which shows he may know everything there is to know about physics, but he knows sweet FA about UFOs. And according to Hawking, this time it's not just the world that's on the block, but the entire universe. And he wrote a foreword to a new book by Brian May, the rock star from Queen, who's also an astronomer, and he writes about a new and unsettling discovery to do with the Higgs boson. It was revealed that the cosmos is actually in an unstable equilibrium, so it's a bit like a pencil balanced on its point. And that if it lost balance in any way, it would instantly topple into a new energy level. And this could happen, theoretically, if the particle was subjected to powerful nuclear forces. Now, unfortunately, the energy level of the Higgs is one of the foundational stones of the universe's physical structure. So it would cause a chain reaction that could spread to all other particles and end up in a vacuum decay, a huge bubble of void, which would immediately form around the location of the first Higgs boson to collapse, and expand outwards at the speed of light until the entire universe was engulfed. Now, this would be the catastrophe to end all catastrophes. And it could happen anytime, anywhere, and we could do absolutely nothing to stop it. We'd have no advance warning of the edge of the bubble approaching the Earth. So there's a new psychological condition apparently called cosmophobia, which is an irrational fear that the universe is dangerous and can destroy you. But it's actually not irrational. There are many forces in outer space that could kill everybody and crush the entire planet. So should we really be concerned by what Hawking has said? Well, yes and no. So all this sort of inevitably leads me to consider what I've said before about the Large Hadron Collider. If the Large Hadron Collider is indeed dangerous, then could it be possible that there are people behind the creation of it and other particle colliders who know this and are still building them for that purpose? As I said, the Götterdämmerung maneuver, the end of their great work of ages. That's the question. I don't know. But I've seen how a crocodile, who is cornered by other crocodiles with its captured prey, will toss it into a river to be lost to all of them because it knows that its rivals are about to steal it. And as we know, the Illuminati are very reptilian in their attitude. So they're like crocodiles. Now, there is good news, I think, which I think could be good news, question mark after it. There are proposed follow-up colliders to the LHC, which could indicate that the LHC is not good enough to do the job. Now, one of those is the Very Large Hadron Collider, which is proposed to be built in China, which is 50 miles in circumference. It's several times the size of the LHC, the size of a city. And there's the High Luminosity Large Hadron Collider as well, which is a proposed upgrade for the LHC. So if these are doomsday weapons designed to trigger the unbalancing of the Higgs boson and begin a vacuum decay, maybe that means that the LHC can't do it. They've tried it, it doesn't work. Now, Stephen Hawking says that to artificially unbalance the Higgs would require a proton beam with the power of 100 billion tera-electron volts. The LHC at full throttle can yield 40 tera-electron volts. And Hawking says that a collider big enough would need to be bigger than the size of the Earth, and he quips that such a project would not be funded in the present economic climate. But could the Illuminati be constructing such a massive instrument on another planet? Maybe below the clouds of Jupiter, or in space near a star light years away? So if so, what can we do about it? That's the question. I've told you the danger, but we need a solution. Well, I'll come to that. And there's something else I want to bring up, another element of the LHC which I think is worth mentioning, and that I think I mentioned this actually. Did I mention this in my Stargate Brighton video? I might have done. I can't remember, but I'll bring it up again anyway. On the evening of Monday, the 24th of November 2014, the city of Manchester in England was rocked by the noise of a huge explosion. There was a storm of social media reports, and the emergency services were put on alert. Yet no cause could be found for the noise. This is very strange because the sound could be heard for miles around, all over the greater Manchester area and beyond. It appears to have been loudest in the Salford area, which is immediately west of the city of Manchester. But somebody I know who lives 7 miles away to the east contacted me to tell me that she and her husband both heard it. Any event capable of generating a noise that loud should be immediately apparent. The local media investigated, and there's no evidence except a column of smoke somewhere near the epicentre, which is an industrial estate at Hessel Street in Salford. The fire brigade attended, and there was no sign of any adverse occurrence. Well, there was a lot of speculation, things about UFOs, aircraft crashes, industrial accident, crashed satellites, etc. However, the real answer could lie somewhere else. That's the question. Anyway, the same thing happened. This is really weird because the following Saturday morning, this is just 5 days after the explosion in Manchester, another very similar event happened. And this took place around 3 a.m. at Catterick Garrison, which is a huge military complex in Richmondshire, which is in North Yorkshire. The police were alerted. Members of the public called to say they'd heard a large explosion coming from the direction of the base. The emergency services were put on alert. The army guard posts stood too, and the A1 main road, which runs beside the base, was closed. But again, the emergency services could find no evidence of any explosion when a blast able to make that much noise should have an instantly manifest cause. So this is very, very strange. The road remained closed anyway, and the area sealed off until the evening, and that caused a lot of disruption to travel. Fans attending major football matches had to be diverted. So a very, very strange thing indeed. Yeah, so it was not terrorism anyway. That was the first thought anyone said. Anyway, the proximity in time to the Manchester incident and the similarity of it, the lack of perceived cause, leads me to think that 2 explosions might be connected. I know there could be many actual causes, but I once read in Nexus magazine concerning mysterious explosive noises breaking out all over the place connected to the Large Hadron Collider. Now, the Nexus article was written by a German researcher, a guy called Olaf Thomas Rabi, and he posits that the high-energy collisions of particles in the LHC cause time-delayed and spatially shifted explosions with a yield of about a megaton, which is bigger than most nuclear bombs. And these blasts would appear out of nowhere and have no obvious physical cause, but they could be traced directly to the LHC operations by calculating when and where they break out. Now, scientists have talked about the existence of parallel universes. Now, this dates back to the physicist Hugh Everett, and this new LHC experiment could find evidence of them. There are anomalies in our own physical universe, like dark energy, strange gravitational effects, and these could be caused by interference from parallel universes. I hope hopefully we'll find the answers to these mysteries, but I'm concerned about the dangers associating with operating the LHC, and there's reason to think that these dangers are not side effects, but actual objectives. What will happen when the LHC is powered up to full throttle? The fundamental structures of the universe could have unpredictable and hazardous effects. It's like undermining the foundation of a house, and the menace posed by Run 2 sees that and raises it. Making contact with parallel universes could mean all kinds of things. What effect would that have on our own universe? Would it cause some kind of universal quantum wave collapse if alternative universes become physically interacted with our own? Or could something from out there get in here, and that could have cataclysmic consequences? Now, the mist. Now, I've talked about the mist before. Like I said, some of this stuff I think I put in my Brighton Stargate video, but The Mist is based on a horror novella by Stephen King, and it runs thus. It's set in a small lakeside town, a short distance from a secret government laboratory. One night there's a terrible storm which blows down trees, and a thick mist washes over the town and reduces visibility to a few feet. Bizarre and unearthly monsters appear out of the mist and start attacking people, and the survivors have to take refuge in a supermarket and wait for help. And inside their impromptu shelter they have to fight off both attempted encroachments by the monsters and their own rising panic and insanity. It's revealed by one of the survivors, an army guard from the laboratory, that the scientists there were working on something called the Arrowhead Project. This is an experiment to open a stargate, a portal between our world and a parallel dimension. So it's frightening. The Mist is a scary film, but it's also very thought-provoking. Now, a friend of mine, Brian Allen, he's very interesting because he's written a lot of books on this subject. He says he believes, and I agree with him, that the UFO phenomena might be interdimensional rather than extraterrestrial. And he even suggests that he's even suggested something which is a real-life parable of the scenario in The Mist, although slightly less malevolent. The Rendlesham Forest incident, which is one of the most important UFO encounters of all times. Now, near where that happened, there was a secret military signals laboratory at Orford Ness. It's closed down since the end of the Cold War. You can still see the huge antenna at the Orford Ness laboratory. The powerful radio transmissions from the station might have weakened or even broken the fabric of space-time that surrounds our universe in higher dimensions, which would have allowed that UFO to slip into our world. This is the question. It's vaguely. I don't know if that's actually the case at all. But there are in the Magician's Nephew, which is the first book. It's the prequel of the Chronicles of Narnia by C.S. Lewis. One of the characters is talking about this very subject, although using different terminology. He says you could meet anything, absolutely anything, and this is true. In a multiverse of higher dimensions, the laws of physics will vary considerably, and the physics of our universe could just be one frequency line. I mean, The Mist is a worst-case scenario, but, well, I hope it is. But maybe it's not. What will happen? We don't know. This is the question when it comes to things like poking holes through the very fabric of the universe, this very bubble we live in, when we don't know what's outside. We don't know at all. Now, I don't watch the Super Bowl. I mean, this is the thing. Americans seem to love all kinds of sports that no one else plays. And one of those is the American football and their big Super Bowl. Their Super Bowl 49, which happened a few weeks ago. But something very interesting happened. Now, during that match, during the halftime break, they have an advert. And the adverts in that break are always like the top slots. They demand maximum viewing figures, and so they are sort of like the elite slots for adverts. Now, what's interesting is that the American electronics firm Mophie produced a very, very disturbing TV advert that premiered during the halftime break for Super Bowl 49. It's a 1-minute commercial, and it shows a world in which all the normal laws of causality and physical consistency break down, leading to a very surreal apocalypse. And at the end of the advert, it is revealed that this happened because God, played by this guy here, did not use a Mophie battery, so his inferior normal battery on his phone ran down too quickly, and his mobile phone packed up. I know it's sort of like a bit of a sort of like black comedy, that advert. Very, very disturbing. If you watch it, I don't think I'll be alone in feeling a bit of a chill. But could this chilling vision have some basis in truth? And maybe even evidence might have been found of that happening. Because a few weeks ago, before Run 2 began, it was reported that an unknown object had been found inside the Large Hadron Collider. It was quickly christened the Unidentified Lying Object, ULO, and it was detected inside the sealed vacuum pipe in the heart of this huge machine. And the announcement was made during a lecture by Professor Albert Daruk, a CERN physicist, and he gave a review. It wasn't recorded, I don't think, but someone from phys.org was in the audience and reviewed the lecture, and he said, Daruk, in fact, has high expectations for the possibility of new discoveries that could change blah, 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 blah. But this is what he was interested in. He said, work remains to be done. One issue the accelerator physicists remain cautiously aware of is the unidentified lying object in the beam pipe of the LHC 17-mile underground tunnel, a vacuum tube where the protons collide. Now this is a concern because the proton beam is very sensitive to the geometry of the environment. The pipe can easily be blocked. the beam pipe must be free of even the tiniest amount of debris. Even something the size of a nitrogen atom could disrupt the beam. Well, because the beam pipe is the beam pipe is a sealed vacuum. It's impossible to know what the object is because no one can look into the beam pipe. The unidentified lying object, it's not a problem yet, according to Duvuk, but it's something to keep our eye on, he said. It's in the vacuum tube and it's not a problem so long as it doesn't move and it remains where it is. Well, I'd like to ask Professor Duvuk some questions. In fact, I'd like to ask him a lot of them. How did something manage to access the interior of this sealed tube where the particle beams flow? It is the most tightly controlled environment on Earth. It's hardly like getting a grain of sand in your camera on Bournemouth Beach. Why is this not a big deal to you, Professor? Something like this should be physically impossible. This phenomenon should make every physicist in the world sit up and think again. How big is this ULO? If you can't see it, maybe you should equalize the tube, open it up, and have a look at this anomaly. Aren't you worried? Aren't you curious? And this situation is not without precedent because objects have turned up before in places where they should really not be. Now, there's a very good book called The Modern Mysteries of Britain. It's out of print now, but there's loads of second-hand copies floated around. It's by Janet and Colin Board, a husband and wife team. And they've captured a lot of these incidents. There's a butterfly trapped inside a riveted gas meter they found once. How did it get in there? A bird was once found inside a car tyre, and there's many, many more. And maybe this is connected to this strange phenomenon of unknown objects falling out of the sky. If something appears inside a completely sealed-off container, then it could not have entered that location unless via higher spatial dimensions. And I do recommend the book Flatland by Edwin A. Abbott to actually describe this. It's an old book, but it really, really illustrates what I'm talking about here. This is now a serious scientific subject, and the activity of the LHC might be directly related to this sort of higher dimensional transport, which means that the high-energy extreme collision operations that have already gone on there might have ripped a hole in space-time, which allows something from out there to get into the universe. And yes, that is a hazardous and irresponsible thing to do. So this unidentified lying object might end up being the first confirmed piece of matter ever to be found that has come from another universe. It would be kind of like a tulpa or a port, whatever you call them, whether you're a spiritualist or a Tibetan. So this would indicate the LHC is already having interdimensional effects that I have long predicted, along with many others. And this is an alarming situation, because you've got to ask yourself, what else can it conjure out of thin air? Maybe this is just a start. Oh, now there's a guy called Glasgow Truther on YouTube. His name's Kev. I've spoken to him a couple of times, I think, but he says that we might be dealing with an object that's currently in quantum superposition. Like Schrödinger's cat, it's going to remain that way until someone looks at it. So maybe it's a good idea it's stuck somewhere in the dark, cold interior of the LHC vacuum torus where it can remain invisible. But for how much longer? Well, I don't know. May this story end happily. I'm not sure how, but, well, I'm going to come on to that in the last part of this video.
So, how will this story end? What's going to happen? Well, a spokesman from CERN have issued a press release stating that collisions have happened, the data tap is on, and the scientific experiments are underway, and the LHC is slowly being powered up to full throttle. And that means collisions of 14 tera electron volts, and that will happen by the middle of this month. And some people like Stan Deyo have claimed that the LHC is capable of even higher energies, and it's already circulated non-colliding beams of 16 to 17 tera electron volts. As I said, these are explosions going on right now that has never been seen. They've never been seen on Earth, never even in the entire universe. So what effect are they having? Now, there's a lot of material online about this. Most of it is nonsense. A lot of it is from a mostly Christian perspective, and people from the American Bible Belt talking about Satan opening the pit, Satan coming out of it, things like that. And And they see, say, the LHC as an instrument of Satan, intended to bring on the apocalypse. Now, some of them make similar points to me, actually, even though we've got a very different religious perspective. It's not just men of the church who have concerns. There are there are fringe elements within the scientific community too. And whatever harm the LHC is capable of, it may be doing it right now. In which case, we just got to wait to see its effects. We've had the to and froing of debates. Wagner, Russler, Sancho saying how dangerous it is. CERN management saying there's no problem. That smiling simian of the small screen, Professor Brian Cox, being among the LHC's staunchest defenders. And that means, actually, it's amusing to think that in the belief system of the American hardline Christians, that must mean that Professor Brian Cox is the Antichrist. Right, disclaimer, okay, that's just a joke. I'm quite certain that his royal cocksness is not the Antichrist, okay, and I don't want you, please don't hurt him in any way. And I'm not religious, but I'm not an atheist either. I believe that there is such a reality to occult powers, which is why you get the Shiva and the 666 CERN logo. The unidentified lying object may be a part of this. However, as far as we know, that ULO has not got in the way, and nothing's been mentioned of it since Professor de Rook brought it up on stage. There's also people talk about a Roman temple being found at CERN, but well, actually, it was actually a villa. It was like a farmhouse they found where CMS was built. But there's a bit more to that. There's where was it? Oh yeah, there's a guy who talked about an Apollon temple, which is near a church, which was actually a Roman town many 2,000 years ago, and it was dedicated to Apollon, a temple to Apollon, which is actually very close to the Mayrin facility at CERN. I don't know about this. I can't see any evidence there's actually that area is charged with geoenergy. Now, you may wonder why I'm still quite cheerful. I can still smile, and surely if the Large Hadron Collider is in the process of triggering Armageddon, and we can't do anything to stop it, and surely I'd be dismal, wouldn't I? Well, I don't think so. I have a powerful intuitive feeling that we're going to be all right. All right. I know that doesn't sound like a lot, but it is. It is an awful lot. I've recently begun watching the videos of Anthony Patch. Now, Patch is a Christian, but he's a lot more knowledgeable. He's a lot more level-headed than most of the concerned community. He's a physicist. He can talk the language the experts use. Now, he agrees with me that the LHC is dangerous, but he shares my optimism. He believes this story is going to have a happy, non-rapture ending. And I'm sure we all share that hope. I mean, I really don't want to give you guys sleepless nights, let alone disturb you to the point where you'll do something, you'll end up hurting yourself. I really don't want that. Remember that the cause of the 2008 magnetic quench incident is not known. So it's almost as if something out there is helping us. And we must remember that. Gandalf from Lord of the Rings, J.R. Tolkien's famous story, he said there are forces for good at work in the world as well as evil. And I very much endorse that. I know I don't believe in messiahs. There's no such thing as us sitting around and waiting for a messiah to come and save us. We humans are masters of our own destiny. It's up to us to create a better world. But I think that attitude can be taken to extremes, to the point where if we're in a such sticky situation and we're helpless, well then that's it. You're all over. Too bad, guys. You're masters of your own destiny, and you've had it. Now bugger off. No, I don't believe that either. I think this "we're masters of our own destiny" thing should not be excessively believed in. And if there is some horrible atrocity awaiting us that is beyond our capability to avent, then someone somewhere will step in and lend a hand. And I will happily swallow my pride and accept. So, whenever I get these reassurances, these strong intuitive reassurances, it always makes me feel better, and they're never wrong. And as Danielle Laverite, who was a guest on my radio show, she said this herself in her videos. She says, somebody's got my back, she says. And I think someone's got our backs. In other words, someone is looking after us. Someone is watching over us. It's not going to step in and guide us, lead us by the hand. No, no. It treats us as adults. It lets us deal with it ourselves to the point where we no longer can. And when we no longer can, it will not just abandon us. It will intervene, and it will put things right. So this is why I would say I really do encourage people to remain calm and remain optimistic. And for God's sake, don't do anything stupid and extreme as a result of the information you've heard in this film. Don't go out and plant bombs or shoot people, anything like that, alright? There's no need for that. Will do nothing, it will achieve nothing. However tempting it might be with Professor Brian Cox. No, I wouldn't hurt. I would never hurt. Brian, I would never hurt you, alright? Okay, you drive me crazy, but I never hurt you. And that could be why the LHC suffers from those technical problems. So maybe it could be that Bellumis will never have their Goethe Dämmerung. Maybe this is why they're planning bigger and bigger Hadron Colliders. That 50-mile one in China. Why would they do that if they had the ultimate doomsday device in the form of the LHC at Geneva in CERN, eh? Anyway, I think this is going to be an ongoing story, so I'll probably be making another video on this subject. But until then, don't have nightmares, as they say on Crime Watch. Hospital porters, pride and dignity, stop the New World Order.